All right, next up we got Evan Tahler. I believe I'm pronouncing that correctly.
Yep,
He's
totally.
going to be talking about sharing TypeScript types across the stack, which is very interesting to me because I really wish I knew this in my last job because I had to write the types both for the back end and the front end. Not fun to change, but go ahead, Evan.
Awesome. I'm going to put myself in spotlight. Hopefully you all can see me. Maybe. Yes. Okay, awesome. Hi, I'm Evan. And this is going to be a bit of a demo, a bit of an explanation. There's code samples up, there's a demo app up, and I'll put all these links in the chat here and in Slack when I'm done. Because for me personally, I'm the kind of person who learns by copying and pasting other people's code. And so I want to give that back to the community. I'm going to try switching myself to my slides. Yeah, magic. All right, awesome. So sharing TypeScript types across the stack. I am a brand new TypeScript convert. I was really reluctant to fall in love with TypeScript, which I have, spoiler. I was burned by the whole CoffeeScript debacle. I didn't want to learn another weird thing that eventually just compiled to JavaScript anyway. And when I attended meetups like this, when I attended Cascadia.js, I really got to see people finally demoing it to me in a way that made me get it and finally realize how it was actually its own language, actually provided its own value. And I'm really glad Mike went first, because the whole concept of static analysis is really what this talk is about. A form of testing that means you don't have to write other tests, a form of tooling that really helps you automatically in your IDEs and things like that. By way of formal introduction, I'm the CTO of a company called Grouparoo, and we are hiring. I do open source for my life, which is kind of awesome. So Grouparoo is an open source company. I also am a maintainer and creator of a bunch of Node.js packages. The Action Hero framework and Node Rescue are the ones with the most stars in GitHub, so I listed those. And at work at Grouparoo, we do this technique. This is where we got to experiment with it and try some things out. So I'll be sharing with you what we learned. Quick note about Grouparoo: it is open source. It is a tool that helps you sync and send your data from your product databases to other places. So if you're the kind of person who at your day job find yourself writing synchronization code, like upload these users to MailChimp or upload these users to Salesforce or vice versa, stop doing that. Use Grouparoo. It'll do it all automatically for you. Handle retries and all that other stuff. That's a pain in the butt. And we do it all with JavaScript and TypeScript. Pitch over. Okay, so the goal that we had was we had these really strongly typed models from our database. We use a relational database, so we knew about columns, if things were strings and numbers and complex types. And we wanted to figure out if we could funnel these all the way through to our front end. And so the goal was to be able in the UI to be like, oh, I know there's a thing called first name and I know it's a string. And if I didn't camel case it properly or something, the TypeScript compiler would yell at us. VS Code would underline it in red, and we'd know instantly if we made a mistake. And if you do that right, there's all these integration tests you can get rid of. A lot of the unit tests you'd write in Jest for your front end can go away. The notion of writing of testing every possible API use case kind of goes away because it's all handled for you. And really magically, bullet number 2 is if you change your backend API to return a new parameter or return additional data, your front end automatically knows about it, and it's kind of handled for you. And it makes doing upgrades in the future a lot easier. So I was thinking about this talk. I thought of what are a thing I know that has types, and I instantly thought of Pokemon because I am a huge nerd. If you recognize the paintings behind me, you will also know I'm a huge nerd. But anyway, Pokemon have types like fire, water, flying, things like that. And so I thought I would use a very scientific data set from the folks at Kaggle, which are known for their data science work and their algorithm kind of contests they put on. And I downloaded the complete Pokemon data sets in a CSV from a fairly prestigious scientific organization to make this little website. It doesn't do much. It just lists the Pokemon and you can sort them by their type. And because we can do live demos. I will turn on my server and I will show you the coolest website you've seen in the past 5 minutes, which is the Pokemon TypeScript example website here. It's booting up. Here it is. So you can, click on a type, see the Pokemon of that type. It's the greatest website in the world. Highly complex, very fancy. All right, so that's what we're going to be making. And in this demo, we'll use the data from the API to figure out what we can do in the front end. Like, can we make an image? What are the properties we're getting back that we can draw on this table? That kind of stuff. So again, the goal is to use TypeScript types as far as we can, get the data from the back end into the front end. And so what that looks like is I have this big JSON file of Pokemon information. Here's a ton of information from Kaggle. And on the right-hand side, here's a React component I was working on that automatically knew to autocomplete name as a property, and it's a string from my data. But I also had Japanese name. I also had percentage male for some reason. And that's kind of the goal we're going for, this autocomplete thing and this type checking back and forth. All right, so some concepts from TypeScript before we get started. The first is that TypeScript is a runtime or a build time language. TypeScript has absolutely no effect on runtime. So what that means is when you're running a TypeScript application, assuming you're using Node.js, you're really just running JavaScript. TypeScript is somehow transpiled magically into regular JavaScript, and that's what you're running. So the whole point of TypeScript is at build time. And the developer experience is considered build time. So what you see in your IDE, what you see in your editor, what happens when you run tests, these are all build time things. TypeScript has no effect on the actual running of your application. So there's no overhead or slowdown or anything like that. Also now, TypeScript is a real language. You can do logical comparisons. You can do loops inside of it. It is almost Turing complete. Although it's really hard for me personally to read, I'm kind of a PHP, Ruby, JavaScript guy. The whole notion of like these weird bracket things to talk about types and whatever's going on here, like I find this hard to read. Most TypeScript applications don't look like this, only complex types. And this is an example from the TypeScript website. And there's only one example of a complex type in this talk. I promise we'll read through it together, we'll understand it. Everything else is going to be really simple. Although for me personally, when I first got into it, it was kind of intimidating understanding some of this craziness. And finally, I asterisk this because this is a personal opinion. You may or may not agree. For an internal project, TypeScript types are better than API documentation. The example server that I have built also includes a Swagger or an open API endpoint, and I'll show you that in a second. So the same data we're getting from our API, we get it documented very nicely with Swagger. So we know that this list endpoint can also take limit and offset and a type that you can filter by. And it still works the same way. And we're using the Action Hero framework here because I'm totally unbiased. But one of the things you get for free from that is also the Swagger endpoint for all your API routes. And so we can kind of see what they both look like, but the tooling you need to get Swagger and doing kind of the IntelliSense stuff into your IDEs is really hard. Using regular TypeScript is really easy in VS Code and Atom these days. And just to show that off in a little demo, there's a Swagger endpoint over here. And so this is the kind of thing, if you were making an API you'd want consumers to use, people outside of your company, you could show it off and you're like, oh, I have a status endpoint that only accepts gets. I'm like, okay, cool, I can try it out. Great, here's an example of my status endpoint. I have a Pokemon endpoint that there's 2 types of gets inside. I can list the types of the Pokemon, which takes no inputs and lets, Pokemon types. And then the list endpoint that we saw earlier. But you can get all of the same information just from a TypeScript type. You don't need robust API documentation if you don't want to build it or don't have the time to. And that's what we'll get into. Alrighty. Oh, and if you want to try this demo out, it's on Heroku. is Pokemon-TypeScript.herokuapp.com. Not that this is a complex demo by any stretch of the imagination, but it is there. Thank you, Heroku, for the free hosting. All right, project setup. Over to VS Code. This is a monorepo project. There's a web folder and an API folder. We're going to be using React and Next.js for the front end. That's what's in the web folder. And we're going to be using Action Hero in the API folder. And this kind of concept we're going to talk through can work for really any API server, as long as API responses are the return value of a function. That's the kicker here. And so what I mean by that is API, source, actions, Pokemon. Here we go. So here is an action from Action Hero. This action returns the list of the Pokemon types. And there is a function run that returns what we want the customers to use. And because it's a function, you can hover over it and TypeScript automatically knows and tells you that, oh, I know that types is a string or an array of strings, and it's in a promise. It's an async function. So because it's the return value, we're going to be able to extract these and use them elsewhere. That's why it has to be the return value of the function. Can be an async function, can be a regular function, asynchronous function. It doesn't really matter. And this works for simple types, like arrays of strings, and it works for complex types, like our list of Pokemon over here, which has this like crazy blob of data from the Pokemon information we downloaded. The TypeScript knows it all. So this is just going through that again. Okay, so cool thing number one for TypeScript, we can actually get the types from TypeScript from JSON files now, which is new as of TypeScript v2.9, it turns out. You have to add these two flags to your tsconfig. So you're saying, hey, TypeScript, I want you to actually read JSON files and try if you can to figure out the types if you can. And if you do that, what we're doing up here is we're loading this Pokemon data from a JSON file, and TypeScript is cool enough that it knows, hey, it's an array, and every object in that array has the exact same properties. So I can actually magically figure out the type of what Pokemon is here. Again, it kind of looks like this. And if you want to see the JSON file, we can do that. And like every Pokemon, like Bulbasaur here, has all this data again. And TypeScript figured that out for us, which is great. Yeah, same thing. Awesome. Okay, so here comes that really scary TypeScript function that I warned you about, the only one. This method, which I called Unwrap Promise, I stole from JP Williams' blog, and it's also a really common helper in TypeScript packages around the web, like Typefest is the one I use the most. And what this is saying is, this is a TypeScript type, Unwrap Promise, that takes in T. So T is some type, any TypeScript type. And what it's saying is, okay, if this thing is probably a promise, infer what's inside of it, that's you, and resolve the promise to try to figure out what you originally is, infer it again. So we use infer 3 times here. And basically what this is going to do is if you give a promise, it'll figure out what the return value of it is, assuming the promise resolves properly. So that's exactly what we were doing over here. So we're like, oh, runs a promise. What does it return? Well, it returns these Pokemon objects. And so this unwrap promise thing we're going to use for the rest of the application to extract the value of a promise and use it elsewhere. And I did a pretty bad job of explaining it. I urge you to go to this blog or use a tool like Typefest to kind of do these things for you. They're common enough. They're built into a lot of framework helpers now. All right, so because TypeScript is a build time concern, not a runtime concern, the front end can use types from the back end at build time and before it. So in our React component, I can import something from the API. And because I'm only using the types, it actually won't be included in the final JavaScript that is run on the server to our customers. This is this whole notion of build time and runtime separation. So even though I'm importing our Pokemon list types at the top here from our API server, it's not actually a runtime dependency of the project. So go over back to the code here, close up the API, go to the web. And so I'm going to go to pages, type index here. So I'm going up in my monorepo, I'm going over API. I'm saying Pokemon list, Pokemon types. These are my API classes. And I'm using this Unwrap Promise thing to get the type of the run method from these classes. Maybe your APIs don't use classes. This is an action hero specific thing, but you can get this method, unwrap the promise, and now I know that I have this response type from that API. So it's the same kind of properties blob that we had before. Same with the type API response. It's a list of strings. So what's awesome about this is if I change my API method, so let's change the Pokemon types method. Maybe it also returns cool is true. I changed my API definition. Immediately, the front end also knows, once it's unloading, that it's getting cool as a Boolean back instantaneously. And so this is how you keep your APIs really tightly integrated with your front end and your back end. So now I can use the cool property of this API response. And if I was to not return types anymore, so I changed my API pretty dramatically, all of a sudden TypeScript's going to know that. And in very short term, I'm going to freak out here. Property types does not exist on my response, which only now includes cool Boolean. Immediately you get an error. Immediately, if I try to run this, it'll fail. You'll get some TypeScript errors. Like right off the bat, something is wrong or right. I want to put that back because I really want types to come back. Give VS Code a second to catch up, and we're back to a good spot. Types is a string again, and that's it. That's the magic. The main thing is knowing that all of this up here does not affect runtime. It's just in build time. And I'm telling my React component that it's using the type of the API response as the props it's getting in. So this is a type string. This is that crazy Pokemon type again. So we accomplished our goal. I didn't have to write an integration test to make sure the API, the front end, and the back end talk well. You saw it go red when something was wrong. And it makes changing and adding features really easy. So for example, maybe I want to add a new column to my front end. So let's add the Japanese name next to the American name. So I don't know what it's called. I don't know the exact property name, but I do know that if next to monster name, I add a line break because I'm old school, and I want to do monster dot something, and TypeScript's going to help us out here. There it goes. Japanese name came from the API. That's a property I have. Awesome. Save. Reload. Give it a second. Oh, demo fail. Well, in theory, that would have worked. And we would have known it's a string. What am I doing wrong? Hey, there we go. Just had a caching issue. And there we go. So now we can get the Japanese names. And it was really easy to know what the API provided without having to reference any docs. Like Mike said earlier, getting IntelliSense and static analysis is really powerful. And one of the reasons I like it at work is that it really helps other members of the team stay in sync. It's an organizational tool. If someone's working on the API and tomorrow somebody else is working on the front end, all this information is automatically here for them to use. Like, oh yeah, I want to add the HP hit points to this as well. There it is. And I know that's the property, what it's called from the API. It's right there. So there's a bonus. And again, I'm really glad I went after Mike, because this also works for tests, which is really powerful. You can do the exact same thing, and you can type, this is a jest test that I have in this project, and we can do the exact same thing. And I'll pull that up. Here's a Pokemon test in jest. So we're testing that we can control the API response with limit and offset in this jest test. And who knows what spec helper run action does, something from our framework. But because I told the test that the response of this is an unwrapped promise of this Pokemon list method, I know automatically that this is what it looks like, and these are the arguments it can take. So if I wanted to also add to my test, Pokemon Japanese name, there we go. I get all the helpers right in the IDE. And if I try to do something silly like, I don't know, Spanish name, like that's not a thing. My test is going to fail, and I'll get an error, and we'll be in a good spot. So that's the bonus of all of this. This really helps with writing integration tests, or even kind of end-to-end tests. A couple of Next.js things, if you're curious. I love Next.js. It's my favorite way to write React. If you were to look at these methods, we're passing in props to our components of the kind of already loaded from the API Pokemon and types. Next has this really cool thing called get initial props. And so here's where we're actually hitting the API. We're fetching, API v1 Pokemon list, API v1 Pokemon types, getting the JSON and returning it back. So in this initial props thing, I don't actually care about the types. Get me whatever the API's got for these endpoints and return them. And this is what comes into the regular component props here. And here's where I'm assigning the types when I'm actually going to use them to draw out my table here. So if you're looking at this as a reference, that's what's going on in NextLand. There is no kind of use effect, load data. Next is doing this magic get initial props thing for us, which loads this up as the page loads. And that's it. That's the magic of sharing TypeScript types between your front end and back end. Kind of hard to get going with that magic TypeScript unwrap method. Once you have it as a helper in your project, remarkably powerful.